Hey, so we're going to start looking at distance versus time graphs, and we're going to be matching up these graphs with different scenarios that are given to us. So let's get started. All right, first scenario. A coach leaves the station at 10 a.m. and reaches the North Station at 11:30 a.m. So he ends up being on the train for about an hour and a half. It stops here for half an hour. So train stops half an hour. Then it carries on for 30 minutes, reaching the West Station 40 kilometers later. So, we need to pick out a graph that shows that something moved for an hour and a half, then it was stopped for half an hour, and then it moves for another 30 minutes. So, go ahead and pause the video and try to make your best guess. All right, so as you're looking at these graphs, notice that all the time is listed on the x-axis, right? All of these graphs are in hours, but not all of them are in hours, okay? So these are all in hours, but the other ones are in seconds. So number 2 is in seconds, and number 6 is in minutes. And obviously number 2 is not going to work because everything happens in 12 seconds. So that is not going to be an option for us. Let's look at number 6. Number 6 is in minutes. We're talking about from 0 to about 90 minutes. That's an hour and a half. Well, our first set of motion was an hour and a half, and then we have more after that. So number 6 is not going to work either. Let's start looking at our graphs. We are moving for the first segment for an hour and a half. So let's figure out the graphs that do or don't have a segment of an hour and a half for moving. So let's look at graph 1. This is the first segment, and it looks like it's moving for 2 hours. So that's not going to work. Let's look at number 4. Number 4, the first segment has it moving, again, for 2 hours. That's not going to work. Number 7, this first segment here is over 3 hours, so that's not going to work either. Number 8, the first segment goes for an hour and a half. Okay, so this one might work. Number 9, so I'm going to circle number 8 so we don't forget about it. Number 9, it says that the person's moving away from the station, and this mark is half an hour, so this one would be 15 minutes. So, plus this graph says that everything happens in an hour and a half, so this one cannot be a graph. So we said 8 might be a graph. Let's look at 5 and 3. So on number 5, again, we're moving away from the station to the left or going back towards home. And this first segment last, well, this mark was the 30-minute mark. So this would be 20, this would be 10. So all that happens in 10 minutes. No, this cannot go with our graph. So now let's look at number 3. Well, number 3, the first segment goes from 0 to an hour and a half. Okay, so number 3 and number 8 could both be possibilities. Let's look at the next motion that we have. So the coach travels from 10 to 11:30. Then the train stops for half an hour. So for 30 minutes, the train is at rest. So let's look at number 8. So from here to here, we do see that the train is stopped. However, how long is it at stop? So it's looking like from an hour and a half to 2.5 hours. So that is 1 whole hour stopped. So that's not what we just read. Let's double check that number 3 is our correct graph. So we have this little segment here implying that the train stopped. And it does go from the 1.5 hour mark to the 2 hour mark. So that is 30 minutes. So yes, number 3 is the correct graph. All right. So go into the next one and notice how for number 3, I went ahead and crossed it off my list so we don't have to think about it anymore. All right, a cyclist rides downhill towards home for 15 minutes. So we know that the first set of motion is for 15 minutes towards home. At the bottom of the hill, she stops for half an hour. So she stops for half an hour next for a drink. Then she continues uphill for the remaining 12 kilometers. All right, so go ahead and pause the video, try to process which graph you think best matches. Okay, so let's start looking at our graphs. Well, the first thing that we can notice is that her first set of motion is actually going downhill towards home. So she's not going away from home. She's going towards home. So on a graph, if we're going towards home, that means that we're starting far away and we're coming back towards our home. So that's going to be indicated by a negative slope. So this graph has a positive slope at the beginning, so it can't be this one. This one has a positive slope at the beginning, so it can't be this one. This one also has a positive slope, can't be this one. Number 5, maybe, because it does have a negative slope at first. Number 6, positive slope, so nope. Number 7, positive slope, so nope. Number 8, positive slope, nope. Number 9 has a negative slope to start off, so it could be 5, could be 9. Let's look at these graphs close. All right, so our first segment where we are traveling home, we only traveled home for 15 minutes before stopping. So let's look at these first segments. So this first segment on number 5, remember we already looked at this graph. This line here is the half-hour mark. So that means that this is 20-minute mark, this is 10-minute mark. So that means on number 5, this person or car or whatever only moved for 10 minutes. So that's not what this person did. She moved for 15. So probably not number 5. Let's look at number 9. Number 9, this is our 30-minute mark. So that means this is 15-minute mark. So for number 9, the first segment, the person does move for 15 minutes towards home, then does take a 30-minute break. Then notice how the remaining 12 kilometers that the person did, if you look at the graph here, 12 kilometers, that's where we start here, and then we go all the way back home. So number 9 matches it perfectly. All right, let's look at our next one. A car travels at a constant speed for 2 hours. All right, so 2 hours on the motorway. It stops at the service station for 2 hours. So we're moving for 2 hours, stopping for 2 hours. Then travels in heavy traffic it must have gotten cropped off. I'm sorry, guys. But it probably was constant speed. All of these are constant speed anyways, for 30 kilometers. All right, so the main thing is we first are moving 2 hours at a constant speed, then we stop for 2 hours. So let's first find those two parts. So again, 3 and 9 we have already used. We're not going to use those again. We've already looked at graph number 5, right? Graph number 5, the first thing was 10 minutes. We should all know that by now, so it's not going to be number 5. We're talking about 2 hours and 2 hours. Let's look at how long these graphs last. So graph number 1, it goes from 0 to 6 hours. So maybe it could be that one. Let's look at number 2. It goes from 0 to 12 seconds. Well, it's definitely not going to be number 2. We're talking about 2 hours. For number 4, we're going from 0 to 3 hours. Well, 2 hours and 2 hours, that's 4 hours. So it's not going to be number 4. Let's look at number 6. Number 6 goes from 0 to 90 minutes. So that's about an hour and a half. Again, not long enough. We need at least 4 hours of graph. Number 7, it goes to 6 hours. So from 0 to 6 hours. So probably could work. Number 8, we're going from 0 to 3 hours again. So 3 hours, not enough. It's not going to be number 8. So we're only looking at graphs 1 and 7. So let's look at number 7. We just looked at that one. So our first segment of motion, it lasts for 3 hours. Is that what we wanted? No, we want something that lasted for 2 hours. It looks kind of similar because it looks like something did go away, then it stopped, then it came back. But that's not really what this car did. This car drove for 2 hours, stopped for 2 hours, then continues in this heavy traffic. So let's look at number 1 and see if number 1 could be it, because number 7, not it. Number 1, this first segment, yes, it does last 2 hours. Then it stops for what is 2 hours. Then it continues going. And notice how it does continue going for 30 kilometers because whenever it had stopped, it was at 120. And then whenever it finished, it was at 150. So 150 minus 120 is 30 kilometers. So number 1 is the graph. All right, Next one, a bus leaves school at 9 a.m. and it gets to its destination at 10:30 a.m. So from 9 a.m. to 10:30 a.m., that's like 1.5 hours. The children look around the museum for an hour. All right, so the bus is parked while the kids are at the museum for an hour, then return back to the school. So keyword, it's returning back. So different motion on the graph. The bus arrived back at midday. All right, so basically what we're looking at is the bus drives away from the school, goes to the museum. The kids at the museum stay there for about an hour. Then they have to go back to the school. So that's the type of shape of the graph that we're looking for, something that went away from the origin, stopped for a little bit, and then came back to the origin. So any graph that doesn't look like that, we are not going to be able to say that that's the correct answer. So we've already used 1, 3, and 9. 4 does not look like what we need it to look like. 5 does not look right. 6 does not look right. The only ones that could be our graph would be 2, 7, and 8. All right, so let's look at number 2. Number 2, our first segment, whatever the object is, would be moving away, but it's at 4 seconds. Sorry, 4 seconds. Remember, number 2 is in seconds. This bus did not go into hyperdrive and travel all that distance in 2 seconds, for sure. So number 2 also cannot be it, because it's in seconds. Let's look at number 7. Number 7, our first segment of data. It says that the object, the bus, the whatever, it traveled for 3 hours. So did that bus travel for 3 hours? Well, it says that it left at 9 and arrived at the destination at 10:30. That's an hour and a half. So it cannot be number 7. All right, let's hope the number 8 is correct. So this first segment of data, it did last an hour and a half. All right, so we're on the same page. This is the bus leaving the school, took an hour and a half. Then from the hour and a half mark to the 2.5 hour mark, it's just sitting here chilling, waiting on the kids, right? And yeah, it was for an hour. That is what we read. Then it goes back to the school. So here it is returning back to the school. So yes, number 8 is our correct graph. All right, a toddler rides his bike up the pavement floor for 10 meters. He then turns around and rides back 2 meters from his home. He hits a bump and falls off his bike. All right, so let's see. We're talking about a toddler moving a short 10 meters. So let's just look for something that moves 10 meters because that should be fairly easy. Well, let's work our way backwards. Number 7. Number 7, it moved 60 kilometers. Nope. Number 6, the first set of motion, 36 miles. Definitely not for a toddler. This one's moving backwards, so the toddler was not returning anywhere. This first set of data, it was 12 miles, so no. Number 2, the graph that's in seconds. Remember, something happening very, very fast. This first set of data has said that an object moved 10 meters. Then he turns around and rides back. So he, real quick, turns around while he's turning around. That he's technically resting because he's just turning. And then he rides back 2 meters from his home. So he rides back towards his home, but notice how he stopped short. He didn't go all the way back towards his home. So yes, number 2 would be the graph. All right, a motorbike rider rides for 36 miles at a steady speed. She stops to read the map for 15 minutes, then rides for the remaining 24 miles at a very illegal fast speed. All right, pause and think about what graph you think it might be. All right, you should have gotten number 6. So number 6, this first set of data, yes, the biker did go to 36 miles, just to verify. A man drives to his friend's house who lives 60 kilometers away, stops for an hour, then returns home. So returns home. This is one where he's going away, stops for a while, returns home. Well, the only graph that's left like that is the number 7 graph. Very good. A cyclist rides for 2 hours, traveling at a constant speed. He then stops to rest for 30 minutes, then continues for a further 18 miles. So he's driving, stops, continues. Well, the only graph that looks like that would be number 4. All right, And we're out of time.